Welcome to section 3, time between events and mastering window functions. This is going to be fun. Right now we're going to take a look at the lag function, and it kind of forms the basis of time since calculations. Also, just forgetting the prior row, it doesn't have anything to do with time necessarily, but it often comes up in the context of how long has it been since. Then we're actually going to compute time between orders for our set of customers and analyze them using Tableau. So we're going to take a look at, what are some of the features of the time between orders. And then we'll finish off with the discussion of the entile function, which is an easy way to do kind of distribution analysis in Excel. The medians, the 90th percentile, stuff like that. You might commonly use Excel or Tableau or ClickView or anything for, but you can actually do a pretty good job of writing Postgres. So the lag function, the basics of, time since or the prior row, this is where it all begins, really. And basically, why does this come up in practice? Well, a lot of times people want to know how long has it been or how long does it usually take for something to happen. Because at its root, business is just a bunch of things that are happening. And anything that happens at a certain time. So it's really fundamental. And I've seen people write Python, complicated R code to compute this stuff, and you don't have to. If you know like 15 or 20 characters, not lines, characters of SQL, and you kind of know what a window function is, you too can use lag. So you could read the definition. To be honest, I read it about 5 times. I don't really understand what it says, but I'm sure it's very accurate. That's how a lot of documentation is, and that's probably why you're watching this course. So without further ado, we're going to jump into the DVD rental database. We're going to look at our payment table. And I computed lag. I'm using payment date. Remember that before our row number function, it didn't take an argument. Lag is taking an argument, and it's doing it over the entire window. So one thing I want you to notice that since we're addressing payment date, what it's doing is it's giving me the prior payment date. So if this is row J, it's going to return the row J minus 1 right there. So you can kind of see this pattern, right? Now, what if I wanted to get the prior payment ID? It doesn't always have to deal with the date. I can get a payment ID. I'll just type it in. I can run it. Why is it upset with me? Because I misspelled the column. It's all right. So notice what's happening here. We have 17503 maps to the immediately prior one. Now, because we're just concerned with getting the prior, we could always get the forward. There is a function called lead, which I've never really used, but it does work. And what it'll do is it'll push out forward items. So we're leading over payment ID. So for this row before 17504, it'll mark it as 17504. So, doing offsets on the level of detail that you're feeding it. Now, next video, we're going to start worrying about the level of detail, but I did want to show you something here. Let's make sure this runs. What if we wanted to compute the difference between these two things? So I'll say that as prior order. If I just wanted to get the time between orders in general, not for any customers, well, what I'm going to do is I'm just going to say select t dot, well, we want positive values, right? So we're going to have to subtract this from that. So t dot payment date minus t dot prior order from T, and I'll also get everything from T, just so we have something to look at. Let me indent that so it's more obvious than not. And what we have here is an interval, and an interval is a data type in Postgres, and you'll notice that it's not all that useful, right? So we have the time between these two orders was 18 hours. The time between these orders, 5 hours, hour 17, hour 22. This took 2 days. This took minus 3 days. So this it almost doesn't even make any sense. So when you kind of just look at it over over this kind of entire window, you realize that you're getting negative differences in between orders. And why is that? So why is that? It's because look at payment ID, right? Payment ID keeps going up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What happens with payment date? Well, yeah, this is kind of funky. Usually in a database, the primary key of the table, auto increment, or will always go up according to some logic, will correspond to increasing times of that insertion. So this database is a little bit funky. If you see this in your own database, you should probably figure out why. It doesn't make a whole lot of sense. But in the next video, we're going to start looking at how do you convert these interval values to actual useful times, and how do we compute this for each customer, not just for kind of orders at large. And the trick is going to be using this. We're partitioning over the entire window. We don't necessarily want to do that. So, try not to overthink it. Lag and its cousin lead, you're just kind of saying, hey, I want the prior row in the partition. So